Alright, so again, there's a typo here. This should be 12.5. So, this is the multiplication rule for dependent events. Objective students be able to find probabilities of dependent events. Alright, so here's the thing. Probability of two dependent events. The probability that two dependent events both occur is a product of the probability, just like independent, that the first event occurs and the probability that the second event occurs after the first event has already occurred. So this means the probability of A times the probability of B given A. That's what this means. The probability of B given that A has already occurred. So this probability is a little bit different. We have to think about how we're going to calculate this individual probability given A. All right. And this is called conditional probability, meaning that this B is based on a condition that has already happened. So if we think about practice 2 from the previous section of notes, right? So the last notes, we had practice 2 where there was 4 blue marbles and 3 red marbles in a bag. However, now after you draw the first marble, you do not replace it before you draw the second marble. Okay, so you're going to take a marble out and you're going to leave it out. That's going to change the probability of your second draw. So now, what is the probability of drawing a blue marble and then a red one? So now, the probability of blue and then red equals the probability of blue times the probability of red given that we've already taken a blue out. Okay, and so let's think about that. The probability of blue is the same because at the first draw there's still 4 out of 7 marbles. But the probability that we draw a red now, there's still 3 red marbles in there, but now there's not 7 marbles in the bag. How many marbles in the bag? You took 1 out of there, so now there's only 6. And so this becomes 12 out of 42, which you could, of course, reduce. You could probably take a 6 out of both of those, you're making it 2 out of 7. So pretty interesting. Definitely a little bit different than maybe what we've done in the past, but pretty cool, right? So now we can see what the probability is, even though the condition is changing. So practice 2, very similar. A magician has you draw a card from a normal deck of cards. Then without replacing it, he has you draw another card. What is the probability they are both clubs? I'm going to let you guys go ahead and try and work that out on your own, and then check back when you're ready to check your work. Alright, so the probability of drawing a club and then a club. Well, the probability of drawing a club initially is 13 out of 52, because there's 13 clubs out of 52 cards. Well, that's a 1 in 4, so I wrote a 1 in 4 here. Then the probability of drawing another club after you've already drawn a club, well, now there's only 12 clubs left and there's only 51 cards left, so this would be 12 out of 51. Before I multiplied, I saw, hey, I could take a 4 out of both of these, the 4 and the 12, giving me a 3 on top and a 1 on bottom, so this is just 3 out of 51. And actually, you could take a 3 out of both of these, because 3 goes into 51 17 times, so this is really just 1/17. And that's it. Let's go to the next problem. So this one, oh, this is getting real interesting. You have 8 coins in a bag. 3 of them are unfair in that they have a 60% chance of coming up heads when flipped. The rest are fair coins. You randomly choose 1 coin from the bag and flip it 2 times. What is the percent probability of getting 2 heads? All right, so really there's 2 events and there's 2 ways. That's the important part. There's 2 ways to get 2 heads. You could either get it the unfair way, I'm going to just say UW, or you could get it the fair way. And so really, since we can get it either one of these ways, we have to calculate the probability of both and then add it up. So the unfair way would require that you first, the probability that you draw an unfair coin, and then times the probability of getting heads. The second is the probability of you drawing a fair coin, and then times the probability of you getting heads. Okay. So this isn't that bad, actually, now that we see it. So what's the probability of getting an unfair coin? Well, they said there's 3 of them are unfair, so that's simply 3 out of 8. And what's the probability of getting a heads? Well, the probability of getting a heads and then heads, that's 2 independent events, so the probability of getting a heads with an unfair coin, they say that coin has a 60% chance. I'm just going to say 6 out of 10. That's what 60% is. So 6 out of 10. Or you could have write 3/5. And this, we want this to happen twice, so we're using the multiplication rule for independent events. We're just saying 6/10 times 6/10. Okay, so this is the probability of us drawing the unfair coin and then flipping heads twice. We also have to take into consideration the probability of drawing the fair coin, which if there's 3 unfair and the rest are fair, that means that there's a 5 out of 8 chance of drawing the fair coin. And fair coins are always a 1 and 2 and a 1 and 2. Okay, so, we could work this out algebraically, but we're going to end up with something kind of nuts here. So I would recommend that you just kind of go ahead and plug this in your calculator. Just remember, when you do fractions, you want parentheses, so it might be a good idea to do this. You could reduce it first if you want. It might make your life a little bit easier, but if you plug all of this in, you're going to get a 0.135 for the unfair coin. So that's the chance that you draw an unfair coin and then flip a heads twice. So really there's kind of like 3 events here happening. And then you could do 5/8 times 1/2 times 1/2. Remember to put parentheses. If you do that, the probability of you drawing the fair coin and then getting heads would be 0.15625. Now I said before, these are both the ways we could get this 2 heads outcome. So we need to add these 2 things together. When you add these together, you get a total probability of 0.29125. So around 29%. So you might think, well, heads is 50% chance. Why am I getting a less than 50% chance of getting heads, even though it's the coin's supposed to be in my favor? Well, let's think about what the probability would be if we only had fair coins. Remember, if we only had fair coins, the probability of getting heads and heads is just 1/2 times 1/2, or 1/2 times 1/2, which is 1/4. Well, 1/4 is 25%. And so we see actually we went from 25% to 29%. So we have a slightly higher chance now of getting heads twice in a row than we did with just fair coins. This is just fair coins, 25%. So kind of an interesting problem. We had to break it up into the two possible ways that we could get that heads. All right. Lastly, here we have a summary. Why is the way we calculate dependent events different from the way we calculate independent events? I want you to kind of explain that back to me in your own words, and don't forget to write your question at the end of the video. See you guys on the next one.